Okay, so this is going to be a review of section 7.4, part 2. One of the concepts we're learning in this section is how to simplify complex fractions. This is when we have fractions within fractions. And it can be kind of difficult, but it is much easier if you can just find the common denominator and multiply through by that. To find the common denominator, I need the factors. So if I look at 5, its factor is 5. If I look at 2, its only factor is 2. 3 only has a factor of 3. 6 has two factors of 3 and 2. So now what I have to do is see what do they have in common. Well, the 2's are in common. For 2, I had a factor of 2. For 6, I had a factor of 2. So I'm going to need to use a 2. For 3, I had a factor of 3. For 6, I have a factor of 3. So I'm going to have to use a factor of 3. And then 5 has a factor of 5. So I'm going to have to use 5. What do I get if I multiply these all together? 30. So 30 is going to be that least common denominator, also known as the least common multiple. That's what I'm going to multiply through by, is 30 here and 30 here. The reason I do that is because my fractions will go away when I do this. So what is 30 divided by 5? And then times 3. 18. So I have 18 minus, this is not over 5 anymore because I divided by 5. On this one, I'm multiplying a half times 30. What is half of 30? 15. On this one, I'm multiplying 2/3 times 30. To do that quickly, I do 30 divided by 3 and then times 2. What is that? 30 divided by 3 is 10, times 2 is 20, plus, and then I can do 30 divided by 6 and get 5. So 18 minus 15 is 3 over 25. And that's a lot faster than you could even type this in your calculator. If you did type it in your calculator, you'd have to use parentheses here, and have to make sure that you were very careful with all of that. Any questions? Yep. Sure. Number 2, we've got x minus 2. That has a factor of x minus 2. X plus 1, that has a factor of x plus 1. X has a factor of x. So, what's going to be the common denominator? They don't have anything in common. Here's a mistake I see. People think that they have an x in common. They don't have an x in common. X is not a factor of this. The only factor of x minus 2 is x minus 2. The only factor of x plus 1 is x plus 1. So I have to multiply every term by x times x plus 1 times x minus 2. This is one of the hardest problems you'll see, and you will have one like this that you'll have to be able to do, so make sure you understand it. When I multiply this times this, the x minus 2's cancel. So all I'm going to have left is a 16, an x, and an x plus 1. When I multiply the bottom, I have to multiply this term. The x plus 1's are going to cancel. So I'm going to have a 4, I'm going to have an x, and I'm going to have an x minus 2. Plus, on the next term, the x's are going to cancel. I'm going to have a 6, I'm going to have an x plus 1, and I'm going to have an x minus 2. Guys, at this point, would I be allowed to cancel the x plus 1's? Yes or no? Factor the x, cancel the x plus 1's. No. The reason why is because this is addition. That makes both of these terms. So I cannot cancel. So I'm just going to have to, the numerator's great. It's already factored. I don't need to do anything with it. But I'm going to have to add these two together. What am I going to have to do before I can add them? Multiply them, right? So when I multiply this, I'm going to get 4x squared minus 8x plus, and I can go ahead and multiply these two. Actually, I like to do just 6 times. I'm going to go ahead and multiply these. X squared. I'm going to have negative 2x plus 1x. That's minus x. And then minus 2. So now the numerator still stays the same. The denominator, though, I'm going to have 4x squared minus 8x plus 6x squared minus 6x minus 12. Again, numerator's fine. If I have 4 of these and 6 of these, that's going to give us 10. Negative 8x minus 6x, that gives us negative 14x, and then minus 12. What can I factor out of this 10, 14, and 12? 2. Good. So now I have 16x, x plus 1, factor out the 2, and I have 5x squared minus 7x minus 6. Does anyone remember how I can quickly see if this can be factored? Multiply 5 times 6, what do you get? Are there numbers that will multiply to be 30 and subtract to be 7? 10 and 3, right? So I'm going to need to get a 10 and a 3. So I'm going to factor this down. I have 5x times x, that'll give me the 5x squared. With the outers and inners, I need to get a 10x and a 3. And I need them to multiply to be 6. How am I going to get a 10x? What do I need this to be? 5 times what's going to give me 10, guys? So that has to be 2. If this times this has to give me 6, what's this have to be? 3. When I do the outers, I get 10x. When I do the inners, I get 3x. I need those to combine to get a negative 7x. So which one needs to be negative? 10x. That comes from here. This needs to be plus. I finally have my answer. Well, actually, not quite. Because I've got 16 and 2. See how now I have everything as factors? So 16 divided by 2 is going to give me 8x times x plus 1 over 5x plus 3 over x minus 2. To find restrictions, I'm going to have to go all the way back up to the beginning. X was not allowed to be 2, x was not allowed to be negative 1, and x was not allowed to be 0. Can I see all of that down here? I can see x can't be 2, right? But what else? X can't be what? I've got this one covered, guys. So I'm going to have to say then that this is equivalent, but x cannot be negative 1, and what else? X cannot be 0. All right, any questions? You know what else too? Like what about x being negative 3/5? Do you see how this one's undefined for negative 3/5? But at the beginning, would it have been undefined for negative 3/5? No. You really would have to have that restriction as well. All right, do you guys see what I'm saying there? How this one's undefined for negative 3/5, but way back up here, the original problem, negative 3/5 minus 2 would have an answer, that would have an answer, that would have an answer. Unless that would be 0. I bet that's the case. I have to explore this. I'm sorry. Hold on. I've got to know the answer. Okay, so what I'm saying is maybe this becomes 0. If I do 4 divided by parentheses, negative 3/5 plus 1, and then plus 6 divided by negative 3/5. I'm hoping that's 0. If that's 0, then that means it's really not a restriction. No, it is a restriction then. Okay, interesting. We haven't had one like that before. Okay, what about this? What did I tell you to do if we have a problem and we're trying to write it in this form? Let's say the problem is G equals, let's say, what do we want? 4x minus 10 over x plus 1. Do you guys remember the easiest way to rewrite this in that form? From the video notes, what was the way we used? Synthetic division, right? What's going to make this equal 0? Negative 1. So I could put negative 1 in the box and then do 4 and negative 10. I bring this down and I get 4. Negative 1 times 4 is negative 4, and I add. What does this represent then? What's this, guys? Remainder. This is the remainder, right? Shh. So that means our answer to this, when we divide, is going to be G equals 4 plus negative 14 over x plus 1. Now, the way they want us to write it is like this. So it's really going to be G equals negative 14 over x plus 1 plus 4. Just to put it in the exact same form. Now they're going to ask you to be able to graph that too. You guys have to remember from Algebra 1 that the graph of y equals 1 over x looks like this. So what's going to happen if we replace x with x plus 1? What's that going to be? A shift to what? Right or left? X plus 1 is a shift to the left. So now instead of having this asymptote here, it's going to be at negative 1. What's a plus 4 do? Shifts at what? Up 4. So we used to have this horizontal asymptote there, but now it's going to be shifted up 4. So it's going to kind of look like this and this. But what does the negative do to it? Reflects it, right? So now it's going to look like, instead of being up and down like that, now it's going to be up here and down here, like that. Okay? Does that make sense? And then this would also, it would have like a, like a vertical stretch, but that doesn't matter. You just kind of need to know the general shape is what we're doing for now. All right? Any questions? Okay.